In this video, we are going to look at different ways of simplifying radical expressions. And we're going to look at radical expressions when your index number, or the power of your radical, is greater than or equal to a 2. Meaning you could have a square root, you could have a cube root, you could have to the 4th root, to the 5th root, and so on and so forth. So we're going to look at different examples and how you might go about reducing these radicals. Okay? So the easiest thing to do is you're going to want to take your radical, and depending on your index, that's going to tell you how many identical terms need to be broken down into a group. And that group that you break it down to is what you're going to pull out of the radical as a reduced form. So what do I mean? Well, let's look at a couple examples here. So first and foremost, I have the square root of 45 n to the 11th. So I'm going to break this into two pieces. I'm going to look at the square root of 45, and I'm going to look at the square root of n to the 11th. So I'm going to treat this almost like it's two separate problems in order to break them down. So the first thing I want to do is I want to reduce my 45. And so there's a few ways that you can do it. One of the fastest ways that you can do it is to break things down according to your primes, but really however method you choose to break down a radical is completely up to you. So let me show you how we would do it if, say, we broke it down using the easiest combination we know, or factors we know. So when we look at 45, immediately what usually comes to mind is that 45 is the same as doing 9 times 5. So I'm going to write them in factored form. Now if I look at this, my index is a 2, which means I need groups of 2 identical terms. So here I have a group of 2, but notice they're 2 different terms. So what I have to do is I have to take this idea and I need to keep going, because I need to factor everything down as far as it can go and try and see if I can find my group of 2. Well, I know the 5 is not going to break down any further, but the 9 does, and so 9 would break down into 3 times 3. And when I look at that, notice I have a group now, and it's right here, of 2 identical factors that are the same value. So what this means is that the 3 pulls or factors out. So here, when we're looking at that, the 3 is going to pull out, but I still have this 5 left in. So here, this is going to become 3 square roots of 5. And that is the most reduced form of the square root of 45. Now I have to do my variable, and my variable is going to be done in a very similar way, only everything we do to break it down is going to be broken down inside your power. So one of the things I know is I know that n to the 11th can break down into n and n to the 10th. Now the reason why I did that is because when we are looking at your variable, we want to be able to set it up that if I had, say, my variable, I'm going to go ahead and write it down here. So if I had my variable, and let's say it was x to some power, and this is under the radical with your index, okay? Then in order to figure out what it would reduce down to, we would have to look at the idea that we have x raised to the power divided by index. And we want to ask ourselves if that reduces, meaning if this actually reduces down nicely and does not leave a fraction, then your power reduced. But if you get a fraction here, then you need to keep taking one away. Okay. So if we look at n to the 11th, 11 divided by 2 is not a very even number. So we have to break it down. So we break one n out and we have 10 remaining. So then what we want to do is we want to look at if I have n to the 10 divided by 2, what does that equal? Well, 10 divided by 2 is 5, so here we get n to the 5th. Because that's nice, what that means is that this right here is going to be my term that pulls out. So n to the 5th pulls out and leaves me with n to the 5th, and then I still have the square root of n. Now the very last thing that we have to do is we have to put it all together. So I have these two radicals here, the number one and the variable one, and I need to put them together. So the rule is you've got outside stays to outside, then your radical sign, and you have inside stays inside. Okay, so when I'm looking at these two terms here, my outsides are going to be 3 and n to the 5th. So this is going to become 3n to the 5th, and then I have the square root, and I'm going to have 5n on the inside. Okay, and so in a nutshell, that's essentially how we break our terms down. So let's go ahead and let's take a look at another one. So look, I have here the square root of 180 x to the 5th y to the 8th. So just like before, I'm going to break this down into pieces. I'm going to have the square root of 180, the square root of x to the 5th, the square root of y to the 8th. And in this case, my index is 2, so that means you need 2 groups. So let's go ahead and start breaking down your 180. So there's quite a few ways that we can do that. One way might be to say that we have 18 and 10. If you look at this, I have 2 groups, but these two numbers are not the same, so we need to keep going. My 18, I know, can break into 2 and 9, at least that's used most often. And the 9 then can break into 3 and 3. Now the other thing I know about the 10 is I know that the 10 here can break into 5 and 2. So if we look at this really closely, notice my first group that I have is right here with my 3's. But then the second group I have shows up here in my pair of 2's. So in this case, we are going to reduce out the 3 and the 2, which means we're actually pulling out 6, but I'll get to that in a second here. We need to do the x to the 5th, so it's going to be the same thing. If we first look at this, 5 divided by 2 is not even. So we have to play the reduce game, so this becomes x and x to the 4th. If we take a look at x to the 4th, notice we would have x to the 4 over 2, which is going to give us x squared. So again, like before, I have this x squared that's going to pull out, and the x is going to stay behind. So here, this is going to pull out as x squared, and my square root of x stays behind. Okay? So getting back to this first one, I have the 3 and the 2. I also have the 5. So when we're doing this, you have to multiply. So these terms right here, you would multiply together, which would mean we pulled out 6 and left the square root of 5 behind. Okay. Now, last but not least, we have this y to the 8th, and 8 divided by 2 works out nicely. It comes out to being y to the 4th, and so that is what pulls out. So when we're looking at this, here my y to the 4th is going to be the term that pulls out. And so therefore we can do the same thing we just did. In other words, what's on the outside stays outside. So we have 6 x squared y to the 4th. Then we have the square root, and we have a 5x. Now let's look at what happens if my index is something other than 2. So notice here, this is my index term. So right there, my power. So here my index is 4. So this says that I want to make groups of 4 identical terms. So I have 16 n to the 12th. So just like before, I'm going to break it down into 2 pieces. So I have the 4th root of 16, and I have the 4th root of n to the 12th. So let's work with the 16 first. So we're going to do the same thing we did before. We're going to take 16 and we're going to break it down to its terms. Well, the easy one is we know 4 times 4. So we want to look at this. How many terms do I have? Well, here they may be the same term, but I only have 2 of them. I need 4 of them, so I have to keep going. I'm going to break my 4 down to 2 and 2, and I got to do it again, down to 2 and 2. So now if we look closely, you can see I have 1, 2, 3, 4 terms. They're all the same. So this is my group. So the 2 pulls out. Now with that, I have n to the 12th, and we're going to do the same thing that we did before. We're going to look at n to the 12 divided by 4. Now since that works out nicely and gives us n cubed, then that is what pulls out. So this is the other piece that pulls out. Now in this case, I want you to notice that the radical completely goes away, and what we're left with is 2n cubed. Alright, so let's look at one that's a little bit more complicated here. So just like before, notice my index here is a 3. So again, this means that I want to have groups of 3 identical terms when I reduce everything down. Okay, so here I have the cubed root of 81. I have the cubed root of x to the 9th, and I have the cubed root of y to the 17th. So let's go ahead and start again with our numbers. So here, one of the things we can look at is, again, we can break things down. And I know that 81 breaks into 9 and 9. If we look at that, notice I do have a group of identical terms, but it only has 2 terms. I want a group of 3, so that means I have to break again. My 9s will each break down into 3 and 3, and I have to do the other one, 3 and 3. Now here, I only wanted a group of 3 identical terms, so here is my group. So the 3 pulls out, but notice there's still 1 left behind. Now the other piece I have is I have this cubed root of x to the 9th. So here, just like before, we're going to use the idea that we're going to look at x to the 9 over 3. Since that reduces nicely and becomes x cubed with no remainder, we know what pulls out. And in this case, my x cubed is what pulls out. Now in this last one, I have y to the 17th. Okay, and this one, hopefully, if you're confused up to this point, will kind of help clear things out when working with variables. So the first thing that I want to look at is I want to look at y to the 17 over 3. Now that does not break out nicely. So here, this doesn't work. Okay, so when we're looking at this power right here does not work. Since it doesn't work, it means we need to take this and we need to break it down. So we're going to pull out a y and leave y to the 16. Okay. So again, my y, there's nothing I can do with it, but y to the 16th I need to look at. So this is going to give me y to the 16 over 3. And once again, when we look at that, it does not break evenly. This doesn't work. Since it doesn't work, it means we need to break it down further. So my 16 is going to become y and y to the 15th. Again, we need to look at y to the 15th. So this becomes y to the 15 over 3, which we know breaks to being y to the 5th. And here we can see that my y to the 5th is what's going to pull out. What's going to be left behind are these two y's right here. Okay, so when you're working with variables, you need to make sure that you continue to break it down until you come up with a fraction that completely divides out perfectly. So now the only thing that's left to do is to put it all together. So the things that are in the circles are what's on the outside. So we have 3 x cubed y to the 5th. We then have the cubed root, and the things that were left behind are right here. So we have the 3, and we have the y, and we have the y. So those are what were left behind. So in this case, we have 3y squared. So there you have it. One method of looking at how to simplify and reduce down your radicals. Okay? So as long as you remember you want to make groups of identical terms, and the number of that goes in your group is dependent on the index of your radical, you should be good. So if you have any questions, please let me know. If you have any problems that you would like to see worked out, please let me know that too. I'd be more than happy to work them out for you. Otherwise, I do hope you enjoyed yourself, and I look forward to seeing you next time.